So, since flexible endoscopy is usually not sterile, it can sometimes confuse students on what they're supposed to do. So, what are some of the things scrubs are supposed to do during flexible endoscopy? I'm glad you asked. First, they're a pair of hands. Sometimes that means they'll stabilize the scope. Sometimes they're the one that does the advancing for the surgeon. If you're ever called upon in your practice to do that task, advancing the scope, be gentle. It is possible to injure your patient, and you do not want to do that. They'll prepare the scopes and supplies for each scheduled procedure. Just like in the sterile OR, we must have our supplies ready for use for our surgeon. They can clean and reprocess scopes. Note the section of your chapter dedicated to the reprocessing of endoscopes to make sure it's done correctly. They take biopsies and specimens, making sure to note the specific name and location of the biopsy, and, since this is a non-sterile procedure, they'll make specimen labels if applicable. And, just like in MIS, they help troubleshoot when necessary. And finally, robotics. First things first, robotic surgery is a minimally invasive technique with computer guidance. Robotic surgery combines the techniques of minimally invasive surgery with computer-guided instruments. So, are we in the OR? Is this a sterile procedure? Will there be incisions? Yes! 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 Know that robotics is rapidly evolving. Therefore, new procedures are constantly being developed and enhanced. Some procedures being performed using robotic-assisted MIS include heart valve repair, lung resections, bowel resections, hysterectomies, and probably most commonly, prostatectomies. The surgical specialties represented by robotic surgery are orthopedic, cardiovascular, general, gynecology, urology, and neurology. Robots are so special because they mimic the movements of the human hand and arm while still outside the body. It's kind of like this open MIS hybrid magic trick. You get some of the best of both worlds. But there are also drawbacks, which we'll get to in a minute. You need to know that the robotic movement is enabled by articulated sections of the robotic arm. What does that mean, articulated? If you don't know, look it up. The science behind the magical movements of robots is the Cartesian coordinate geometry system. This system is what makes the robot closely resemble the actions of the human body, because each arm on the robot controls an instrument in the body and is equipped with the ability to allow the arm to move up, down, side to side, back and forth, just like the human hand. The other major advantage of robotic surgery is the fact that the image is displayed to the surgeon in 3D, just like an open procedure. When the surgeon is operating from within the console, it's like they are immersed in a world that is the patient's anatomy. Isn't that cool? Oh! Your book briefly discusses the classifications of robots and as being either servo robots or non-servo robots. This classification is used for all types of robots, such as industrial line machines that perform single action functions like screw the lid onto the tube of toothpaste, to robots like the Da Vinci. The Da Vinci is a servo robot because it is capable of many functions and is sensitive to what is going on, like knowing when the instruments are being switched in and out of the arms, that it should lock those arms in position so as not to inadvertently harm the patient. No one has to lock the arms. It just does it, and then it unlocks them when the new instrument is seated properly. You need to know that the Da Vinci system is the only surgical robot system in the United States that is approved for telesurgery. What is telesurgery? Telesurgery is the super cool technique used when instruments are controlled through a remote, non-sterile console by the surgeon. So the robot is over here, and it's going to do whatever the surgeon tells it to. From over here. Does that not blow your mind? All these advantages make it seem like robotics is a slam dunk, right? Well, there are some disadvantages to robotic surgery. So let's compare them and contrast them. Robotics has a leg up on other techniques because it allows greater depth perception and increased precision over traditional MIS. It also projects its images in 3D, just like if the abdomen were open before their eyes. Also, the robot can reduce the effects of hand tremors and movements, and it closely replicates human movement. The disadvantages are that it is incredibly expensive. Oftentimes, facilities do not reap the investment made very quickly, if at all. Robotics also requires an on-site coordinator available to troubleshoot at all times. Surgeons and staff must receive extensive training through their facility and the various manufacturer training seminars offered across the country. Finally, the robot takes away the haptic feedback that surgeons have been trained to perceive all their careers. Do you remember what haptic feedback means? The absence of it is a major adjustment that surgeons must make. You'll notice that the instruments used in robotics are similar to regular MIS instruments, which are in your textbook. While you will get to handle a small selection of MIS instruments in the lab, we don't currently have any robotic instrumentation on site. This picture shows you someone in a training facility learning how to use the robot, and she's putting an instrument into the draped robotic arm. Notice how it is long and skinny at the end like an MIS instrument, but has the large block at the top for the robotic arm articulations. Another thing I want you to pay particular attention to in the clinical sites is how the robotic arms get draped. Draping weird things like robots and microscopes and C-arms can be such a daunting task, but it's doable. And more importantly, there's an aseptic way and a contaminated way to do it. Take a look at this picture. She's got 3 to 4 separate robotic arms to drape for her procedure. Notice how she is facing a draped arm while draping the second arm. This is intentional. She is facing her sterile field and not turning her back to it. She is not trying to squeeze between 2 non-sterile fields while draping. She is executing her plan aseptically, and that is going to keep her patient safe. Now, I'm going to show you a short video of the actual draping process, and understand you may see some alternative methods in your clinical experience. But as long as the drapes are sterile, you're good to go.
The non-sterile staff member prepares the first arm for draping and delivers the patient cart arm drape to the sterile field. The sterile staff member prepares the arm drape. Once the drape is prepared, he or she lowers the drape over the top of the arm and attaches the instrument arm sterile adapter. Then, placing his or her hands inside the drape cuff, he or she moves the drape along the patient cart arm at the 6 and 12 o'clock positions towards the column. Once the drape is extended over the arm, the sterile staff member attaches both metal discs on the inside of the drape cuff to the magnetic sockets at the top of the arm so that the flex strip is facing the front of the arm. He or she then aligns the cannula mount sterile adapter and clicks it into place. Then, the sterile staff member releases the tearaway tab on the back of the drape and carefully slides the drape material away from the gray handle. He or she stabilizes the gray handle and snaps the arm clip into place. Then the sterile staff member bends the flex strips to create a U-shape for a clear instrument insertion path. The sterile staff member then completes this process for the remaining arms.
One last thing. Each of these drapes costs about $60, so no pressure. Next, it's important to know how the robotic OR is set up for success. The robotic surgery equipment should be positioned in a manner so that it is protected from contamination. There are equipment positioning guidelines available which facilitate this type of setup. It's very important, for all surgeries really, but especially in robotics, that the operative setup be pre-planned so that anesthesia time is not used for tasks that should be taking place before surgery. Here you can see a typical OR setup with the patient bed, the patient cart, also known as the robot, the console, anesthesia, and the sterile field. Note how it looks slightly different than the traditional OR. Finally, it's important to understand the roles everyone plays during these procedures, as they're slightly altered from what you've been exposed to thus far. First, the surgeon. The surgeon will still scrub in at the beginning of the procedure to make incisions and place working ports, and then they will break scrub and leave the CST and the assistant to work from within the console. The surgeon will do the entire operative portion of the procedure from the console, provided there are no major complications. There is a microphone inside the console and a speaker on the robot, so when the surgeon speaks to the console, the team can still hear what he or she is saying. The surgeon scrubs back in at the end of the procedure to remove specimens and ports and close the incisions if the assistant isn't permitted to do so. Second, the assistant. The assistant is sterile the entire procedure and exchanges instruments on the robotic arm. If permitted, they may assist with the removal of specimens and closure of the port sites. This will depend on their credentials. Third, the scrub person. This person is also sterile the entire procedure and performs tasks associated with robotics preoperatively, such as the preparation of the equipment and necessary adjustments. While in the sterile role, the scrub will also assist with instrument exchange and troubleshooting on the field. Finally, the circulator and/or coordinator. This person's role remains very similar to that of the circulator and in a non-robotics room, but they need to have knowledge of how to get the robot docked once the ports are in place and needs to be able to troubleshoot from the non-sterile field when necessary. Some facilities have a designated position for the coordinator, and this person can either be an RN or a CST. CSTs that both scrub robotics and are coordinators must have extensive knowledge of sterile and non-sterile functions of the robot. So what's coming up in your Surg 202 future? On Thursday, you'll take your Organization of the Human Body exam, and immediately thereafter, we're going to the lab. Be sure to wear your scrubs, and I'm going to open your eyes to the supplies and equipment to MIS. We'll review these videos, grade your workbook, do a little discussing, and I'll show you my MIS setup. See you soon!